In the previous lectures, we have seen how dysfunctional adipose tissue is linked to the development of many non-communicable chronic diseases. In this video, we will examine the connection between obesity and lower respiratory tract infections. Although there are several causes of respiratory tract infections, in the following lectures, we'll focus on influenza and coronavirus infection. The flu or seasonal influenza is typically caused by influenza A or B viruses. While most illnesses are brief and without consequence, influenza can also cause severe illness or even death. In temperate countries, although viruses are detected year-round, the influenza epidemic reaches its peak during winter months. In the Northern Hemisphere, the flu season starts in October and it can last as late as May. Tropical countries show less seasonal variation. Influenza viruses circulate all year long. In certain regions, peaks occur during the rainy season. Since various respiratory tract infections may show similar symptoms and patients often do not seek medical attention, we don't know the worldwide incidence rate of influenza. Estimates range from as low as 54 million to as high as 1 billion cases of influenza a year. The 1918 influenza pandemic, also known as the Spanish flu, was caused by the H1N1 influenza A virus. Lasting from 1918 to 1920, it infected 500 million people, about a third of the world's population at the time. Since the outbreak of the Spanish flu pandemic coincided with the end of World War I, there are no reliable statistics available. Mortality estimates range between 17 million and 100 million people. The Spanish flu was definitely one of the deadliest pandemics in human history. The 2009 swine flu pandemic, responsible for more than 18,000 deaths worldwide, was also caused by H1N1 virus. Based on serological studies, it is estimated that 11 to 18% of the world's population was infected by swine flu. In addition to these numbers, the 2009 pandemic was also a turning point in the history of obesity research. As a consequence of the 2009 H1N1 influenza pandemic, obesity was identified for the first time as a risk factor for severe outcome. In 2009, a study was conducted in the United States analyzing the clinical characteristics of California residents who were hospitalized with H1N1 infection. The main objective of the study was to assess whether obesity is a risk factor for severe outcome or death. The body mass index data of 534 adult patients was correlated to the outcome of the H1N1 infection. Researchers found that 51% of the patients were obese. Obesity is defined as a body mass index of 30 or higher. Among California adults, the prevalence of obesity is only 23%. Based on these data samples, it is 2.2 times more likely that obese individuals develop influenza-like illness due to H1N1 infection. In addition to severe outcome, obesity is also a serious risk factor for dying from influenza caused by H1N1 virus. The odds ratio of the group of BMI above 40 is 2.8, while in the group of BMI above 45 is 4.2. In other words, the fatality of influenza progressively increases through body mass index. Obesity worsens the outcome of respiratory diseases several ways. Obesity results in altered lung mechanics and physiology. Already mentioned in the previous parts that in obese individuals, the excess body fat that lines the chest and occupies the abdomen limits the action of the respiratory muscles. Adipose tissue around the airways narrows down the luminal diameter of the airway and increases resistance. In obese individuals, these physical changes impair the efficiency of gas exchange. Besides these factors, obesity is also associated with important changes in the immune system. In addition to its energy storage function, adipose tissue is a highly active metabolic and endocrine organ as well. Adipocytes secrete a whole range of cell-signaling molecules called cytokines. This chart summarizes the most common cytokines produced by the adipose tissue. These adipokines have either pro-inflammatory or anti-inflammatory effects, and their balance is crucial in maintaining homeostasis. Obesity leads to dysfunctional adipose tissue, resulting in an adipokine imbalance, ultimately causing a low-grade chronic inflammatory state. The next slide depicts the model of adipokines action in H1N1 infected patients. The left side of the chart shows the adipokines activities in a lean individual. Adiponectin and other anti-inflammatory adipokines are released at a higher concentration compared to an obese individual. High levels of adiponectin suppresses T-cell-mediated responses and innate immune responses. In addition to that, adiponectin reduces pro-inflammatory cytokine production. The right side of the chart shows the adipokine activities of an obese individual. Adiponectin is produced in decreased amounts in obese patients. The activated macrophages produce increased levels of interleukin-6, tumor necrosis factor alpha, and reactive oxygen species, which contribute to the chronic pro-inflammatory state associated with obesity. As a result, obesity is characterized by a state of a chronic, low-grade inflammation and altered response to infection. The innate immune system of obese individuals who have low adiponectin levels is hyperresponsive to pathogens compared to healthy people. The response of an obese person to H1N1 infection is more intense than that of a lean person, as the levels of pro-inflammatory mediators are elevated. In addition to the severity of the outcome of an H1N1 infection, obesity also affects the population dynamics of influenza A viruses. Obesity promotes the emergence of virulent variants within an influenza virus population. Furthermore, both the amount of viral shed and the duration of positive samples for H1N1 virus significantly increases in obese individuals compared to normal weight people. Although this is a relatively new area that hasn't been studied before the swine flu pandemic, there is a massive amount of evidence that obesity is correlated to the duration, severity, and transmission of respiratory diseases.